We train a random forest regressor to rank cities by fit score. To reduce latency, we cache database calls. We use a custom target function combining housing price, income, and home features and environmental quality with exponential decay to reward closer matches. Our pipeline included imputation, scaling, encoding, and a column transformer to handle both numeric and categorical data. Our model actually achieved an R squared score of over 95% on an 80% holdout set, and the predicted scores followed a normal distribution. For a $550,000 home and a $90,000 income, it ranks cities like Helena, Montana, and Olympia, Washington as top matches based on affordability and living.
Logistic regression works when you need to sort outcomes into categories instead of predicting a number. It produces probabilities between 0 and 1 so you never get impossible values. And its S-shaped curve handles nonlinear patterns and its coefficients show how each factor changes the odds. Linear regression, by contrast, isn't meant for yes or no predictions and can give values below 0 or above 1. And we utilize this model in order to showcase possible differences between logistic regression and linear regression.
Here's our code for our most recent polished KNN. We took a lot of steps modifying it to eventually improve it, all shown in this IPyNB in the GitHub. We had accuracy tests. You know, it was modified to increase the accuracy, and all of that is shown here. There's just a very quick, brief showing. Here's it running. We have our top 5 cities here. I'll just make a quick modification. Temperature was hot. All of those cities are somewhat hot. And then changing it to cold, we get definitely impacts the results.
The model for housing data too. We have some of the R squared scores of some of the features, for example, cost of living and employment, and we also have the estimate accuracy of the whole model, which is around 85%. And if we scroll down, we can see based on some couple of user inputs, the model is able to spit out the top 5 matching cities based on the input given below above. And we have a quick visualization to give a better picture.
About the motivation section. So basically, when we were coming across this project, we were looking at the real life counterparts such as Zillow and Airbnb, and we realized that they are a filtration system. So they use user input and filter results based upon that. But what we decided that kind of our model would take, the approach our model would take would be trying to mitigate uncertainty and also overwhelming the users with extensive surveys, because before they even look for a house, they should be comfortable with the area that they're looking for a house in. And what our system does, each of our models try to recommend a top 5 cities that they can use first to see where they want to live in. And this basically uses user preferences, so 1 to 6 questions, and they don't have to answer all of those questions. And we pair that with the housing and quality of life data that our model uses to recommend those cities. And we're trying to maximize satisfaction and minimize buyers' remorse.